Alright guys, today we got three more proof for congruence, triangle congruence. So the first one is angle side angle. If two angles and the included, again the keyword is included, side of one triangle are congruent to two angles and an included angle of another triangle, and then the triangles are congruent. So if you look at these two triangles, by the tick marks and by the angle marks, I can conclude that angle A is congruent to angle D. Side AB is also congruent to side DE, and angle B is congruent to side angle E. Excuse me. Now, again, it's included side, so the side must be in between the two angles now. So it's similar like side angle side, but it's just the inverse way. It's the other way. So it's angle side angle. The side gotta be in the middle of the two angles. So again, like we talked about yesterday, it's gotta be in consecutive. Angle side angle. Angle side angle. No matter where you go, angle side angle. You get angle side angle here. Alright. The second one is angle side. Do not mistake this with angle side. Again, we cannot prove two triangles are congruent by angle side because you know what it spells. But angle side, right? We can prove two triangles are congruent by angle side. So again, by the tick marks and by the angle marks, I can conclude that. Well, let's read the definition first. If two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the triangle are congruent. Misspelling there. That's supposed to be congruent, not included. But, right, so I can conclude that angle A is congruent to angle D, again by the marks. Angle B congruent to angle E, and side BC is congruent to side EF. Let's look at it again. Angle side. Angle side. Or you can call this side angle. Side angle. Alright, either way, you can do it both ways with this one. Alright, and the last one, we got HL. HL is called the hypotenuse leg. Well, called the hypotenuse leg because we're gonna use the hypotenuse of the right triangle and one of the legs. So it says if the hypotenuse and a leg of one right triangle is congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. Again, so all you need here is a hypotenuse that are congruent and just one leg, not both of them, just one leg of the triangles, of the right triangles that are congruent as well. Right, so over here, by the tick mark, I can say that side BC is congruent to side EF. And that's the hypotenuse. It says the hypotenuse is the sides opposite of the right angle. Again, I made an arrow. That's the right angle opposite from it. Side BC, that's the hypotenuse. The longer side, or the longest side of the right triangle. Same with this guy over here. The right angle is over here, opposite from it. Side EF, the hypotenuse, the longest side of the triangle. Alright, and one of the legs, BA, is congruent to ED. Right? So you need one, again, the leg, the hypotenuse, and one of the legs that are congruent. Alright, so let's check out a couple of examples. Let's see. The first one here is congruent by angle side angle. Alright, this is the back of your notes. Number one, you have an angle, you have a side, you have another angle marks. Again, got to be in consecutive. Angle, side, angle. Alright, so we can prove number 1 by angle, side, angle. The next one, number 2, I can prove it by HL. Don't forget from yesterday that we got these two triangles conjoining over here. Alright, they share a common side. Yesterday we talked about if two triangles share a common side, their measurement, they're always congruent. So I made two tick marks over here because you already had the single one to say that, hey, this line is congruent to itself pretty much. And also, I know this line is congruent to this line. Well, we can see that these are two right triangles over here to this right side and to the left side as well. So guess what? This is my hypotenuse. This is the hypotenuse for this side. This is the hypotenuse for this side. So I have one pair of hypotenuses that are congruent, and one of the legs are also congruent. So hypotenuse, leg, hypotenuse, leg. So we can prove this. Two triangles are congruent by HL. Number 3, right? Well, number 3, when we look at them, we have angle, side, side. Angle, side, side. The angle's not included, so they're just on the side, and again, it spells that word. It's not congruent. Alright, but if that angle is in between the two sides, let's say this angle is here instead, and that angle is here instead, then yes, it'll be side, angle, side from yesterday. The last one that I want to talk about is this guy. This is number 4 on the bottom. It's angle, angle, side. Alright, don't forget, whenever you see a shared side, alright, they're always congruent. So I have angle, angle, side. Alright, again, it's got to be consecutive, clockwise or counterclockwise on the sides of the triangle. So I can't do angle, side, angle. You skip this side and skip this angle. You can't do that. You got to do it in the consecutive. Angle, angle, side. Angle, angle, side. Or side, angle, angle.